Okay, so just going over this question, let's just check it's recording. It is. Right, so it's a projectile question, and it says that it is projected at a height of 0.8 meters with a projection velocity of pi plus qj meters per second. A cricket ball is hit from point A, so it's hit here, with velocity that, as I just said, at an angle of alpha above the horizontal. I and j are the usual horizontal and vertical component of the unit vectors. The point A is that I just said that. The ball takes 4 seconds to travel from A to B, so I better mark that on t equals 4. Okay. OB is 64 meters as shown in the diagram. By modeling the motion of the balls right freely under gravity, so I've got gravity going on just here, which is my G. It says find the value of P and Q. Okay, so for that to happen, right? So we can do this all in one go. We can say that using SUVAT. No need to give direction for this. I'm going to stick with using vector format. We know that U is equal to PQ meters per second. I know my displacement is equal to 64 and negative 0.8 because it's going downwards from that position there. Okay, that's meters. We've got time is equal to 4 seconds, and it says find the value of P and Q. Well, we know the acceleration is equal to 0 in that direction and minus 9.8 in that direction there. Okay, so I'll just underline that so it doesn't get in the way of things. U, S, T, and A. So that is S equals UT plus a half AT squared. Okay, so S, well, we know that that is 64 minus 0.8. Okay, is equal to UT, so that is 4 lots of PQ plus half AT squared. So I've got T squared is 16, half of that is 8, lots of my acceleration vector, which is 0 minus 9.8. So I can just rearrange that by throwing this over and then dividing by 4. So I've got PQ as a vector is actually equal to 64 minus 0.8. This comes over, so it becomes a minus 8, lots of 0 minus 9.8, and then I'm going to divide it all through by 4 to give me my answer for P and Q. And does it say it wants an answer for P and Q? Where it is? Find the values of P and Q. Yes, I'll have to find individually. So P is equal to, well, let's get the calculator out and let's work it out. It's 64 times nothing divided by 4. Well, that is 16. Okay, and Q, well, that is minus 0.8. I can get a calculator out for this. Minus 0.8 plus brackets, never trust calculators, 8 times 9.8, get an answer and then divide that by 4 and we get that, which is SD 19.4. so 19.4. Those are the values of P and Q. Okay, find the initial speed of the ball. Well, that's part A. You know the velocity of the ball, the initial velocity, you've just worked that out, is PQ, so that is 16 19.4. So let's rub that out. Let's put b over here, and let's call that u is equal to, so therefore mod u is equal to the square root of your 16 squared plus your 19.4 squared, all square rooted, and that will give us the speed bit of it that we need. So click that up. I've got to square root the answer squared plus 256 equals, and does it say anything? Find the initial speed, so it's 25.1. Can't go any further than that because we've used g. 25.1, so 3 sig fig meters per second. That's the initial speed. Right, find the exact value of tan alpha. Okay, so tan alpha, well, I've got them in two components now. So this is part C. I've got the projection, and it went across, and it went up, and it was projected at that angle there, which is alpha. And we know the horizontal component is 16, and the vertical component is 19.6. And it says find the exact value. Well, we know that tan alpha is equal to the fraction opposite 19.6 over 16. Obviously you can't have a decimal within an exact fraction, so let's just work that out. 19.6, I think that's what it said. 19.4 in fact, isn't it? 19.4, that's lucky. 19.4, start again. So delete 0.4 divided by 16 equals, and as an exact fraction it's 97 over 80. 97 over 80 is the answer for tan alpha. It says find the length of time for which the cricket ball is at least 5 meters above the ground. So 5 meters above the ground is set. Now the ground is just here. Okay, so in other words, we're looking for 0.8 less than that, so we want to know, set our height here to be, take 5 from that gives you 4.2. So we're now going to use SUVAT in componentalize it, so we're going to split the vectors up to the different components. This is part D, and we're going to use SUVAT and say that up is positive. That will give us our u. Well, our u component is in the positive direction, is 19.4. So 19.4. Our a is equal to minus 9.8 if I'm saying up is positive. Always be careful of the signs. S, well, I'm saying up is positive and I want an upwards movement of 4.2 meters. And T is what I want my answers to be. Now it's going to form a quadratic. It's going to give you the time from here to there, and that was going to be our T1, and then it's going to give you the time from here all the way to here, which is my T2. So the difference between T2 take T1 is the time that it remains above the 5 meters above the ground. Okay, so let's get back to this equation here. So I've got S equals UT plus a half AT squared. So S, well, that's your 4.2 equals UT, so that is 19.4 lots of T plus a half AT, so that's going to give you minus 4.9 T squared. So forming this quadratic, throwing everything onto this side, so I've got 4.9 T squared minus 19.4 lots of T plus 4.2 is equal to 0. So using the quadratic formula on a calculator, or I'm going to have to use the old-fashioned thing here, I'm going to put down T1, which is the smaller value, and T2, which is going to be the biggest value, and they're both going to be positive. Okay, so clickety-click. Let's get the biggest one first of all, so square root minus b, so that is 19.4. plus the square root of b squared, so that's 19.4 squared, minus 4 lots of a, which is 4.9, lots of c, which is 4.2. Okay, close brackets, come out, go down, and 2 lots of a is 9.8. Okay, and SD it. So or equals, I got 3.73, and I'm going to store that. Shift, I see. Oh, I have to do that again now. Answer equals, anyway, shift, stow, answer, and storing as A. So 3.73, 3.73 seconds is that bit there. And T1, I'm going to have to start that all over again, because you can usually go back and repeat. That's a right nightmare. Anyway, fraction button, start again. It is minus b, 19.4. It's minus the square root of 19.4 squared minus, open brackets, 4 lots of a, which is 4.9, lots of c, which is 4.2, close brackets, come out, go down, and that's 9.8 equals, and it gives us that, which I'm now going to press shift, stow, B, and that is 0.2, I didn't see it, is it 22? No, it's 230, 230 seconds. Okay, so therefore height above 5 meters for T2 minus T1 is equal to, and that is going to be my alpha A minus my previous answer equals, and 3 sig fig, that becomes a 3.50, 3.50 seconds. Okay, that's above 5 meters. I can only go to 3 sig figs. We've used G somewhere. Right. State an additional physical factor which may be taken into account in a refinement of the model of the above model to make it more realistic. That's a 1 mark thing. E, you need to take into account, so take into account of air resistance, full stop. Use a more accurate value for gravity, for G, or you could even say take into account the spin, but those are the 2 main players they're going to give you marks for. Okay, so that is that question done. I hope that helps and makes sense.